Chapter 2 of the book, the textbook of this course, is dedicated to uh, some techniques and some methods and what we should know about data and pre-processing of data. We will start with data objects and type of data. As we talk about it in the first chapter, type of data that can be turned into data mining methods is different, completely different. For example, data mining techniques can accept uh, regular records of data. For example, something like this. In slide 3, you can see a table, a very common table. Okay, it's a data matrix, and we can accept it and work with this data. Okay, it can be about different documents. It has it consists of data included in some documents. For example, in document 1, 2, or 3, there are some words, and you can see number of that words. For example, in document 1, the word team is repeated 3 times. The word coach is not appeared in the document 1, but it's appeared in document 2 for 7 times. It's a record, or it's a matrix of data. Maybe our data is prepared in a graph form or in a network form. For example, the World Wide Web, the internet. For example, social networks or molecular structures. Some data are ordered. What it means? Ordered means data comes one after another one. For example, in a video data, during each second of video, you will see 25 to 30 frames, one after the other. It's an order. 5 to 30 images comes after each other. You cannot change this order. Sometimes we are working with time series. For example, data of a monitoring systems in a hospital or in a power plant or something like that. Some data are sequential. For example, transactions in a bank. Some data has multimedia nature. For example, a video, an image, a voice, a map. You know that the multimedia contents are far from a document, for example. If we look on their structures, on their skeleton, on their natures, they are far from each other. In the context, you can see it, some words, sentence, and paragraphs, or something like that. But in a video, you are talking about lots of frames, comes after each other, and each frame has a dedicated size, and it consists of lots of pixels. Each pixel has its own information, so they are far from each other. Let's have a look on another table. For example, uh, this is a table dedicated to a market. Uh, Someone comes and buy bread, coke, and milk. Someone comes and buy beer and bread. The third one comes and buy beer, coke, diaper, and milk, and so on. You can see something like this in the data set. This is another type of data. Okay, but what we should know here, it does not important which type of these data is important in data mining. But what is important is that firstly, we should create a structure for data. Maybe your data is structureless. Okay. So one problem is that how we can make an make an structure, make a structure for our data. Some data are structured. When we create them, they are structured, but not all data. Also, we have other problems too. For example, uh, if I have an image with a size of 400 in 300, my image has size of 400 in 300 pixels. It means I have 120,000 pixels. So I have to work, if I decided to work with this image, if this image is an entry for my uh, job, I have to work with something like this, an image with size of 400 in 300 pixels. I can see a very large and a huge amount of data here. 120,000 columns. One column for each pixel. So the dimensionality of my data is very high. We say curse of dimensionality here. How can I handle something like this? 120,000 different dimensions. It's too hard to handle something like this. In a regular table or in a relational table, number of dimensions is low. For example, each record has 20, 30, 40 or something like that. Number of features in a record. It's a low, but in multimedia, number of dimensions or columns is very high. So the curse of dimensionality is the problem in such cases. Some data are sparse. For example, if we talk about marks of students. These marks, these marks are limited in the range of 0 to 20 marks. Okay. But what about the distance in galaxies, between galaxies? They are far from each other. For example, if I talk about the distance between the Earth and in a star, between the Earth and stars placed in a very far galaxy, in another galaxy. Okay. When I talk about this distance, and if I compare this distance with a distance between the Earth and the Moon, for example, the distance between the Earth and the Moon is very close. The Moon is very close to the Earth. If I talk about stars in another galaxy, the distance between the Earth and the Moon is very close. So this sparsity makes some other problems for us. So how can I talk about this sparsity? For example, if I try to uh, present an average, just a simple average. I'm deciding to calculate a simple average. The distance between the Earth and the Moon is nothing when I'm talking about the distance between the Earth and stars in another galaxy. The average will be shifted toward that distance. Sometimes we are talking about the resolution of data. For example, I'm working in a chain uh, in a chain store market, for example, something like Walmart. Okay, if I'm talking about data in each branch, I can look data one by one, each record of data one by one. But when I'm talking about data in a country, in all branches in a country, I cannot work with all data one by one, all records of different branches. It's, these data are too much. So I have to change my resolution. I have to prepare some summary reports from each of the branches, and then in an upper level, I have to work with those summaries, not write with each of those records. I cannot work with them directly. So sometimes I have to change my resolution of work. I have to be clear about the scale of my work. It depends on different situations. Sometimes I should be clear about the distribution of data. For example, sometimes I should be clear about the centrality of data. What does it mean? It means that the center point of a group of data. I have a group of data or group of points. Imagine I have a group of points in the space, and I'm looking for the center of them. Sometimes, sometimes this center is placed in the center of the overall structure of those group. Sometimes this center is placed in one corner of that group. It depends on the situations. Okay, but before all of these, I have to prepare some basic introduction about data objects. What is data objects? We say that all data in data sets are arranged in data objects. In other words, a data object is an entity. What is entity? I can, in some places, I say um, a record. It depends on different situations. And what is inside an entity or inside a data object? It depends. For example, if I'm working with say databases, then my entity or my data object can be dedicated to customers, can be dedicated to items in the store, can be dedicated to sales, regular sales in the store. If I'm talking about medical database, healthcare systems, maybe my entity is information consists of informations about patients, about treatments of patients. When I'm talking about the university, my entities maybe are students, professors, courses. I can define data objects and entities as a student, as professor, as course. In different areas during the time, sometimes we say data objects, sometimes we talk about entity, sometimes we talk about sample, sometimes we call it example, sometimes we call it instance, maybe we call it data point, maybe object, tuple, record. There are different names, all of them from our perspective. All of them are data objects. They have a similar meaning. All of them means data objects. An object which is included data about something. I don't know what's that, but it's something in the word. Okay, and when we look some in this way, when we talk about data object, for each entity we can present some attributes. For example, when I'm talking about a student, the student has a student number, he or she has a name, a family, an age, uh, major, a phone number, address, and something like that. When I'm talking about a professor, he or she has uh, some similar data. So Each data object or each entity consists of some attributes. These attributes describe that data object, that entity. So in a database, I can create a structure about these data objects upon uh, their attributes, found their attributes. Each row of this database or this table is a data object, and each column is an attribute. Look at the table. Each row is a data object or record, and each column is an attribute. Also, we can say attribute is dimension. When we are talking about dimensions, it means we are talking about attributes of a data object or of an entity. Also, sometimes we call them features or variables. So attribute, dimensions, feature, and variable, all of these are same together. They means a data field. It consists of a very specific characteristics of that data object. For example, when I'm saying name of the student or a student's name, it represents something special. It's different from the family or age of that student. Okay, when we are talking about these attributes or dimensions, features, or variable, one more interesting topic or interesting aspects for us is type of these attributes. Basically, we have three types of data: nominal data, binary data, and numerical data. Numerical or quantitative data are divided into interval scale or ratio scale data, and we should talk about them more deeply. Nominal data means name of a category, name of a state, name of something, some name of things or something. For example, when I'm talking about color, hair color or color of something, what is black or brown or gray, white, red? What is black? It's a name. Why they say black? For example, can I say it's not black, it's this color is black or something like that? It's a name. It doesn't mean. In Arabic, I think it's aswad means black. Yes, I think aswad is black. So what does it mean? Aswad. What does it mean? It's a name. It's not nothing more. For example, what about some categories? Some, for example, zip code, occupations, marital status. So nominal dedicated to names. And what does that name mean? I don't know. It's a name. I don't know why they called it something like that. For example, black in English means siyah in Farsi, and in Arabic it means aswad. So what does what do they mean? I don't know. It's a color, nothing more. And what is different between white and black? I don't know. They are two different types of color. I cannot put a weight for them. I cannot compare black and white together. If I decided to do something like that, to compare, for example, black and white, I should find a measure for that. I cannot directly work with them. Next type of attributes is binary. Binary is a special case of nominal type. When an when a nominal attribute has only two states, for example, true or false, 0 or 1, man or woman. This is a binary attribute. Only two types of two state. Only we have two states, nothing more. But what is the difference between man and woman? Nothing. They are just two names, nothing more. What is the difference between true and false? Nothing. It's just they are just two names, nothing more. Sometimes these binary types, these binary data are symmetric. Sometimes they are asymmetric. What does it mean? Symmetric means that the outcomes of both states, outcomes of both states are equal. For example, finding a chance between, for example, I'm going outside. What is the sex of at the fixed sex of the first people which I see in the outside, which I visit? Is that people is a man or a woman? I don't know. Maybe 50% is man, 50% is woman. The gender or sex of the first people that I will see next time is something 50-50. 50% I will see a man firstly, and in the next 50% I will see a woman. So the chance of this outcome is completely equal. So this is something symmetric. But for example, I'm going to outside and deciding to test the status of health of people. For example, I prepared a package to test COVID-19. Okay, what is the outcome? What is the result? The result is that most of the people which I test them are healthy. Some of them are sick. Only some of them are sick, and some of the people have COVID-19. So the outcomes is not equal. Most of the people are healthy, and some of them, most of the people are in good health, and some of them are sick. This is asymmetric. Just maybe 1 or 2 persons are sick, and 99 or 98% are in good health. Medical test is the best asymmetric binary example for us. Okay, some of attributes, nominal attributes, are ordinal. What what it means? What does it mean? It means that the values are nominal again. Okay, are nominal again, but they also have an order or a ranking uh, inside them. I know I will, Mohammed Hassan, I will finish the class in a few minutes. Okay, I'm clear about that. I will finish the class in a few minutes. Okay, for example, when I'm talking about the size, a small, medium, and large, there are some names, name of category or name of things, I don't know, name dedicated to size. When I'm talking about the grades of marks, about mm, talking about the army rank, all of these sets, size, grade, army ranking, or something like them, there are specific names in the set, but they have a rank too. They have an order. Firstly, we should talk about small, then medium, and after that, large. There is an order in their nature. And okay, we will talk about this slide, and after that, we will finish our today's class. The last part of attribute types is numerical attribute. The attributes in slide 7, all of them are qualitative qualitative attributes. Uh, they just have a name and nothing more. But numerical attributes are quantitative attributes. They have a value. I can compare them easily using their values. Maybe an integer or a real, I don't know. I'm not sure about them. But they have a value. I can compare them easily. Numerical attributes are divided into two categories: interval attributes and ratio attributes. Interval attribute means that there is a measurement with equal size units. Okay. For example, the temperature in Celsius or Fahrenheit or calendar. What is important is that in interval attributes, I have no true 0 point. What does it mean? It means that what is the 0 point in calendar dates? Maybe someone that says the calendar is standing for the year which the Prophet Muhammad Rasulullah hijrat from Mecca to Medina. The Muhammad Sallallahu left the Mecca toward the Medina. This is the starting point of the calendar. Okay, but what about the before of this time? Before of that hijrat? What about that days? So when we are talking about the intervals, we have no a true 0 point. But in ratio, we have it. true 0 point. For example, when I'm talking about temperature in Kelvin, we have a real 0 point in Kelvin. When I'm talking about length, what is the length of this car? It has a 0 point, completely 0 point. What about the counts of money, for example? It has a real 0 point. So when we are talking about the ratio attributes, it means that we are talking about values starting from a specific point. It has an order or magnitude uh, based on a unit of measure. We have still a unit of measure, but we say that, for example, this vector is 5 times larger than that vector. So we have a unit vector. We talk about the order or magnitude order with respect to that unit vector. So the difference, again, the difference between the interval attributes, interval numerical attribute, and ratio attribute is the 0 points. The intervals has no true 0 points, but the ratio has a true 0 point. This is their difference. But in reality, in practice, we just talk about numerics and nominal data types, which that is interesting. Here we talk about nominal, binary, ordinal, and interval and ratio data types. But in practice, we just talk about numerical and nominal data types. Okay, that is enough for today. I will see you on Thursday, inshallah. Again, I'm sorry for the delay in the class, in today's class. Again, is there any is there any question? What about the rest? Is there any question?